Problem 12, and there is this ugly looking equation and we need to find the solutions. So what this means that this is actually the cube root of x squared minus the cube root of x minus t equals 0. Well, we know that we can put anything into the cube root, that's no problem. So the domain is certainly a set of real numbers. No one said anything else, so that's what we can assume. And this is of course quite ugly looking, but if you write it like this, or, well, you can even write it like, it's 1/3 squared minus x to the power 1/3 minus 2 equals 0. Then you see that if you squint at it, oh, this is a quadratic. So we don't like this x to the power 1/3, so we can put it into a new variable. So u equals x to the power 1/3. And if we rewrite that, so now we have, oh, sorry, it seems that I left out 3 here. Okay, so we had multiplying by 3, so therefore, well, it was not too late. 3 times u squared minus u minus 2 equals 0. And this is an ordinary quadratic in u. So, well, solve the quadratic. Okay, you can use the formula, or you can use some other tricks like completing the square. It doesn't matter. Maybe the formula is the easiest. Just make sure that you document what you did. So this will give us u equals 1 and u equals negative 2/3. Okay, but this is not our original variable, so now we can sort of unpack the complexity again, and we say that, well, x to the power 1/3 equals 1. Well, then certainly it follows, if I cube both sides, which I can do, x equals 1. And also I have here, so it's like x to the power 1/3 equals negative 2/3. Again, just cubing each side, I will have x equals negative 2/3 cubed, which happens to be negative 8 divided by 27. Okay, well, it's maybe it's easier to keep that one. So now we need to check, and this is the most common mistake, is that people forget that, well, you have to have the solutions substituted into the original equations in order to check whether we have a proper solutions, and not checking this intermediary quadratic. Or sometimes even people take this and substitute into that one, which just doesn't really make any sense. So we have, well, 2 solutions, x equals 1. Now I'm checking the original equation, so it's 3 times, well, let's just take a power, it's just 1 minus 1 minus 2. Oh, that's 3 minus 1 minus 2, that's really 0. Okay, so that's not much work here. But then we also have negative 2/3 cubed. Okay, that's a bit more challenging, but it actually will work out very nicely, because we have the cube root of negative 2/3. Well, okay, it's cubed and squared. I'm trying to save some work here. Minus negative 2/3 cubed, and that's under the cube root, minus 2 equals, okay, so well, that will be 3 times. Now I take the cube root of something cubed, so I get negative 2/3 squared minus negative 2/3 minus 2. Okay, so what do I get here? I get 3 times 4/9 minus 2/3 minus 2. So that is, well, it's like, that is 4/3 minus 2/3 minus 2, and that doesn't seem to be 0. So where did I make the mistake? Can we salvage this one? Oh yeah, because that's not minus 2/3, that's plus. Okay, that's where the error crept in. So that's plus 2/3. Okay, well, now it's fine because we have 6 divided by 3, and that's 2 minus 2. Oh, that equals 0. Okay, so that was a mistake in the computation because this was negative. Then I forgot to do negative times negative. Okay, well, that's another good lesson here. So if you trust your solution and you don't get it in the checking process, then might be that you did a mistake in the checking process. Okay, but now we double checked it and it works out.